Okay, folks, welcome back. This is session 3. Today I'm going to introduce the first component that we're going to talk about, and that component is the resistor. Go ahead, take a minute, copy this, pause it. So the resistor is what they call a passive component. It just kind of sits there in the circuit. It really doesn't do anything, but it's an electronic component that functions based on the property of resistance. Now, from last time, we learned that resistance is the opposition to the flow of current offered by a simple friction. That means there's stuff in the way that the electrons have to fight their way through to make it, and it slows these electrons down, so it limits current. Typically, a resistor is used in support of other devices. They limit current, so if we have a device that's sensitive to current flow, we'll put a resistor in the path to limit the amount of current flow that can flow through that other component. So it is one of the more common components. So our whole deal here is introduce what it is, the kind you're going to see. But more importantly, we need to determine how to check it and determine if one is good or bad. And so the lesson for session 3 is probably going to be in 3 videos, this introductory video. Then we'll do the color code, and then we'll do schematic symbols as the last one. Okay, so first thing I want to tell you is there are different types of resistors that you're going to run into. The types of resistors, the first one is the carbon composite resistor. Now, the carbon composite resistor, if you look, is the most common resistor out there. And why do you suppose it's the most common? Yeah, it's the least expensive. See, the process for making these carbon composite resistors is they mix a carbon powder, sometimes they use graphite, and with a ceramic type base, and they add a binder in it, and it just creates these long tubes, and they bake it and extrude these little resistors out the other end. Now, this whole mixing process, if you ever made a cake or anything like that, you know that you get clumps of stuff on the side of the bowls, and if you don't scrape it real good, you get a clumpy cake mix. Well, the mixing process, and this is similar to that, better obviously, but similar. And so what we have is when we mix this, if I make, say, for example, a batch of 1,000 resistors, and let's say these are 100 ohm resistors. Well, out of those 1,000 resistors, I may get 950 of them that measure 1,000 ohms. However, because of the inability to mix completely, I may have some resistors that run anywhere from a little less, like 95 or 98 ohms, up to a little more, 93 or 103, 105 ohms. So we have this range of resistance. So we need to, based on this variance in components, determine how far off it can be and still be considered good. So we're going to be learning about how to check resistors to determine if they're good or they're bad. That's really the whole point in this whole lesson. So the carbon composite resistor, the most common because it's the cheapest. And then the next one is the wire wound resistor. And we see that the wire wound resistor is used in high heat and high power applications. The wire wound resistor is a ceramic base. And you fire ceramic in kilns up to 1800 degrees. So the ceramic itself can handle a whole lot of heat. And then they use tungsten wire, which is the same wire that they use in incandescent lamps or light bulbs that can handle, again, that amount of heat, but still offer resistance. So they take this tungsten wire and they wrap it around these ceramic bases, and depending on how much wire they use, they can determine the amount of resistance of the component itself. But the ceramic and the tungsten wire both are capable of handling high temperatures, and as we learn later on, electrical power will also be transferred into heat. So high heat, high power applications interchangeable at this point, especially in reference to this resistor. Now, because we have these different values, these variances, some applications for resistors have very, very precise values required. And because of that, we have to have some very, very precise value resistors, and that's where the film type resistor comes in. The film type resistor, several different types of film that they put on the base substrate of a component, but then they actually turn and cut away the amount of resistance element in order to leave the value of resistance, and each one is done individually and checked, and therefore the precision or the actual value is going to be very close to that design value. Now, when I say very close, I'm talking 0.00. We're talking thousandths of a percentage in variance on these. So film type, very precise values, but also very expensive. Okay, so the carbon composite, the wire wound, and the film type. So this is the first section. I'll be back and we'll go over the color code here in just a minute. Okay. Oh, I thought of a joke. I got to share my joke with you. If you don't think it's funny, well, then, just don't laugh. But here we go. So how many electrons does it take to screw in a light bulb? Electrons don't screw in light bulbs. They wear them out. All right.